on a graph of the sine cosine functions. And we'll learn how to sketch the graph sine f of x equal to sine x. Okay. Typically, they look like this. Okay, I'm gonna get to detail how to sketch a graph of this. And cosine okay, this is cosine graph. And if you look at domain range, domain is from negative infinity to infinity, meaning all real numbers, so extend in both directions. And range for both sine and cosine functions from -1 to 1. For this basic for those two parent functions. All right. So in this particular section, we take a look at how to sketch the graph of basic sine, cosine functions. And we're going to understand how to find the amplitude in a period to help sketch the graph of sine and cosine functions. And we learn how to sketch transformation of the graph of sine and cosine functions. Translation is the same thing as transformation. Okay. Now, first of all, we take a look at basic sine, cosine curves. For sine curves, you'll get a sine curve for first period or one of the period. So let's assume f of x equal to sine x. Here the amplitude equal to 1 and then period equal to 2 pi. And for this we need 5 order pairs for one period. Alright, so you see period is 2 pi, so you're going to split that into 4 equal parts, meaning each partition should be 2 pi over 4. So it's split into 4 equal parts. Each portion should occupy pi over 2. So a sine starts with 0. Then we add in pi over 2, you get pi over 2. Adding another pi over 2, you get pi. Adding another pi over 2, you get 3 pi over 2. Add another pi over 2, you get 2 pi. Right. Now you find the y values, meaning when I see what is f of 0. F of 0 is sine 0. Sine 0 equals 0. Okay. F of pi over 2. So which is sine pi over 2. Sine pi over 2 is sine 90 degrees. It reached the maximum 1. And next order pair will be f of pi. Sine pi. Sine 180 degrees equals 0. Turn back to the 0 again, and then f3 pi over 2, sine of 270 degrees equal to -1. And then eventually f of 2 pi. Sine 2 pi is the same thing as sine 0 because it's adding one revolution or one cycle, then equal to 0. Alright, so that's 0. And once you have 5 order pairs, and if you sketch the graph using those 5 order pairs, 0, 0, up to 1, pi 0, 3 pi over 2, common -1, and 2 pi common 0. And we should be able to get the sine curve. And this is one cycle right here. If you look at it, this is 0, 0, goes here, 0.00. and this is pi over 2, 1, and this one is pi 0 again, and this one is 3 pi over 2, comma -1, reach the minimum, and then for this period, the last point is 2 pi 0 again. So you connect those two 5-order pairs with a curve, smooth curve. So basically you get a one cycle, or one revolution of the sine function. Okay. And definitely sine has infinitely many cycles, so you can extend it on both directions to get the next cycle on the left hand side. Okay. Okay, extend it to the right to get next period. But yes, this is basically the one of the period here. Yeah, that should be the sine curve. If you look at cosine function, you're looking at f of x equal to cosine x. Similarly, you're going to have 5-order pairs, just like what we have over there. Start from 0, and then similarly, the amplitude here is 1, and then the period is 2 pi. So similarly, we split the period into 4 equal parts. Then you're going to get 2 pi over 4. And simplify, you get pi over 2. So now you add pi over 2 to the starting point. You get pi over 2 for the x coordinate, and then pi, 3 pi over 2, and 2 pi. And then similar, again, with next step, we find the y values. So let's see what is f of 0, meaning f of cosine 0 turned out to be 1. And then f of pi over 2, cosine pi over 2, which is cosine 90 degrees, equal to 0. And then f of pi, cosine pi, it's -1. And then f of 3 pi over 2, cosine 3 pi over 2, equal to 0 again. And now again, f of 2 pi is cosine 2 pi. Cosine 2 pi, you're adding one cycle, one revolution to the starting point, so you still get 1. So once you have that, those 5-order pairs, and then plot it, right? 0, 1, goes here, pi over 2, 0, pi -1, 3 pi over 2, again becomes 0, and then 2 pi, comma 1. And those 5 points goes here, 0, 1 goes here, pi over 2, 0, it's right here, pi and -1. 3 pi over 2, 0, and then 2 pi, comma 1. Now again, you connect those 5-order pairs within the smooth curve, 2 points at a time, connect it with smooth curve. Then we get one period of a cosine function. And similarly, you can extend it in both directions to get the remaining of the cycles if you want to. Just extend it. Alright, you can get as many cycles as you want. It has infinitely many cycles, because x value go from -infinity all the way to infinity, right? And yep. So if you look at it, they have a similar curve. If you look at sine function, actually is symmetrical with respect to the origin, right? So on both sides of the equation, or both sides of the y-axis, they form a mirror image based on the origin. So that's why sine function is the R function. So meaning f of x equals sine x. Sine x is R function. And if you look at the cosine function, it's symmetrical with respect to the y-axis. And that's why this is an even function. With exactly opposite x values, y value is the same. Y value is the same. So that's why it's an even function. That's we learned it from the previous section. You know, sine, cosecant are R functions. Cosine and secant are even functions. Tangent, cotangent are R functions. We also get it from the graph. So again, sine curve is symmetrical with respect to the origin, where the cosine is symmetrical with respect to the y-axis. So that's why we know sine is an R function and cosine is an even function. Now, as you can see, we're using 5 key points. 5 key points is the intercept, maximum point, and minimum point, right? Intercept, 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 maximum point, and minimum point. Okay. And then for cosine function, very similar: intercept, intercept, maximum point, and minimum point. Okay. So once you have those 5 points settled, and you'll be able to graph any sine or cosine functions. And for example, let's say we have a y equal to 2 sine x. You want to graph on the interval negative pi to 4 pi. So first of all, we need to look at amplitude. Amplitude is the number in front of the sine x, so take absolute value of that, it becomes 2. Meaning the maximum minimum is going to be 2 and negative 2. And then period equal to 2 pi over the number in front of x. Number in front of x is 1, so it's 2 pi. Now, for one of the period, so basically just increase the amplitude to twice as much. That means we have we call this a vertical stretch, right? Because the y value becomes twice as much. So right here, similarly, we're going to have 5 order pairs for one period. We'll still start from, I guess we're going to just put some more order pairs. Pi. Yeah. 5 order pairs together with so negative pi first, and negative pi over 2, and 0, and then pi over 2, pi, 3 pi over 2, and 2 pi. We can keep going, right? We can have some more. Maybe, I guess, let me just erase this, put in more order pairs. Get all these coordinates, and I can start to graph it all together. First one, negative pi over 2, 0, pi over 2, pi, 3 pi over 2, and 2 pi. And then we get 5 pi over 2, 3 pi, 7 pi over 2, and 4 pi. Right, that will cover all these key points, right? But if you look at the one period, it will be from 0 to 2 pi. That will cover one period, one period. Yeah. and anything else is outside of the 1 period. But since we want to get a complete picture, so we need all those key points. So the y value here equal to sine 2 times sine of negative pi. We know sine is r function, so it's negative 2 times sine pi. Sine 180 degrees equal to 0, negative 2 times 0 give us 0. Okay, we get the first order pair, second one y equal to 2 times sine negative pi over 2. Again, sine is an r function, so we get negative 2 times sine pi over 2. Sine 90 degrees equal to 1, so negative 2 times 1 becomes negative 2. And then 0, y equal to 2 times sine 0, 0, 2 times 0, that becomes 0. And then next one is y equal to 2 times sine pi over 2. Pi over 2 is 90 equal to 1, 2 times 1 gives us 2. And we have where the function reached the maximum, y equal to 2 times sine pi. Sine 180 degrees equal to 0, so 2 times 0 gives us 0. Y equal to 2 times sine 3 pi over 2, so 2 times negative 1. Sine 270 degrees for negative 1, so it's negative 2. So y equal to 2 times sine 2 pi. Sine 2 pi is the same thing as sine 0. 2 times 0 gives us 0. And then y equal to 2 times sine 5 pi over 2. Adding 2 pi to pi over 2. So sine 5 pi over 2 is the same thing as sine pi over 2. So it's 2 times 1 gives us 2. So y equal to 2 times sine 3 pi. Again, you're adding 2 pi to pi. So 3 pi should be the same as sine pi. So it's 2 times 0 gives us 0. And y equal to 2 times sine 7 pi over 2. 7 pi over 2, you're adding 2 pi to 3 pi over 2. Then you get a 2 times negative 1, that becomes negative 2. So y value is the same here. These two are the same. These two are the same. Last one, y equals 2 times sine 4 pi. Sine 4 pi is same thing as sine 2 pi. So the y value will be the same, 0. Two times 0, 0. Now once you have all those ordered pairs, now you can sketch the graph and you end up with this. Start first one is this is negative pi 0. Second order pair, that will be negative 3 pi, negative pi over 2. And this is negative 2. From the table, we get the same order pairs. And then go back to 0, 0. And you shift all the way up to the maximum point. This turned out to be pi over 2, 2. And go back down to the intercept, and this one is pi, count 0. And now 3 pi over 2, you reach the minimum, negative 2. Maximum is 2, minimum is negative 2. Okay. And then go back down, we get 2 pi, 0. And 5 pi over 2 turned out to be 2. Reach the maximum again, and go back down, so we get 3 pi 0. And next one is a 7 pi over 2, and reach negative 2. Last order pair, that's going to be 4 pi and 0. Go back down to the x-axis, and you connect all those order pairs. You can also list all of this into the order pairs and then plot those and connect those graphs. As you can see, compared to original parent function, so the gray one is the parent function, which is y equal to sine x. As you can see, it's a vertical stretch, meaning it's on the vertical side becomes more stretched. You stretch towards the vertical dimension, so that's why we have a vertical stretch. So meaning when the coefficient becomes bigger than, so when the coefficient a becomes bigger than 1, then we have vertical stretch. If the a is between 0 and 1, we get a vertical shrink. Just like similar concept when we talk about the transformation back in chapter 2. Now amplitude, let's get into the amplitude and period in more details. So if let's say we get a model of sine function y equal d plus a times sine of bx minus c, for cosine function y equal d plus a times cosine bx minus c. And right here, if absolute value of the a greater than 1, then we get a vertical stretch. Just like what we talked about earlier, if absolute value of a is less than 1, then we get a vertical shrink. Understand it from the transformation point of view. And amplitude is the maximum minimum the function could reach. So for both y equal to a sine x and a times cosine x, amplitude is absolute value of the coefficient in front of the function, sine x or cosine x. So amplitude equal to absolute value of the a. Amplitude could be maximum or minimum, right? If it is positive, then it's maximum. If it is negative, then it's minimum. Okay, amplitude and refraction. For example, let's say we get a y equal 3 cosine x, and then the other function is y equal negative 3 cosine x. Since the y value becomes opposite, so it's a refraction about the x-axis. So that's why this is a refraction. X value is the same, and y value now becomes opposite. So it's a refraction about x-axis. So that's why you see that the gray one is a 3 cosine x, and then the black one, that's a negative 3 cosine x. They reflected about x-axis for the mirror image on the x-axis. And the period, typically if you have a function y equal to a times sine bx, or y equal to a times cosine bx, so the period equal to 2 pi over b, right? So basically you just divide in 2 pi, which is original cycle by b. Okay, so divide by b, you get a period. We're assuming p is a positive real numbers. If you also want to make sure it's always going to be positive, you can also put absolute value on top of b. So guarantee that it's always going to be positive for b. And if b is greater than 0, less than 1, the period of a equal to sine bx is greater than 2 pi, so we have a horizontal stretch. Okay, represents horizontal stretch, meaning one revolution become longer, horizontal stretch. And then b, if b is greater than b is greater than 1, then it's a horizontal shrink because the cycle becomes shorter. So we have a horizontal shrink. So b is greater than 1, then we have a horizontal shrink. Because the cycle becomes shorter. Okay. Now let's sketch a graph of y equal to sine x over 2. First of all, the amplitude is the coefficient in front of the sine x over 2, so it turned out to be 1, so amplitude absolute value of 1 becomes 1. And then the period is going to be, you can write it as sine half times x. Okay, so period will be 2 pi over half, absolute value of half. So 2 pi over half becomes 2 pi times 2. Divided by half becomes multiplied by 2. It's the same thing. So that's 4 pi. Meaning that since b is greater than 0, less than 1, we have a horizontal stretch because the period becomes longer. Instead, compared to original period is 2 pi, now it's 4 pi, twice as much. So it's horizontal stretch. We do expect that. Now let's sketch some graph. Okay, get some order pair, sketch it. So we get y equal to sine pi over 2. And we need 5 order pairs, just like the other one. And again, period is 4 pi. So you divide in the period and divide period by 4, you get an increment pi. That means again you start with the 0 and then adding pi to previous x coordinate to get next x coordinate, 3 pi and 4 pi. You see, then we get a complete period here. 4 pi minus 0, that's a complete period. Now we find the y value, y equal to sine x over 2. So 0 over 2, 0 over 2 is 0, sine 0 turned out to be 0. Okay, we get the first order pair. Second one, y equals sine pi over 2. Pi over 2 is 1, so it's equal to 1. Third one, y equals sine 2 pi over 2. So it becomes sine pi. Sine pi equal to 0. Third one, y equals sine 3 pi over 2. Sine 3 pi over 2, 270 degrees is equal to negative 1. Okay, then last order pair, that will be y equals sine 4 pi over 2 will turn out to be sine 2 pi. Sine 2 pi is same thing as sine 0, that turned out to be 0, just adding one period to the beginning point, right? Look at that. Now you have 5 order pair, 0, 0, first order pair, pi 1, second order pair, 2 pi 0, 3 pi negative 1, and then 4 pi comma 0. So now you can sketch the graph. For equal parts, pi, 2 pi, 3 pi, and 4 pi. That complete one period. Maximum is 1, minimum is negative 1. Now start plotting all the pair. This is origin. Then pi 1 reach the peak, and then 2 pi 0 go down, so you get a cycle, yes. And then 3 pi reach the bottom, minimum, and 4 pi go back to 0. Okay, extend it. So we get first period right here. Okay, so that we get a 1 period of sine. We're going to label this y equals sine x over 2. That should be good. And that's how you sketch a graph of sine x over 2. Now, we may encounter more complicated cases with the translation of sine and cosine, meaning we have some more transformation on top of vertical distortion and horizontal distortion. Now, we looking at this when we have y equal to a times sine bx minus c, or y equal to a times cosine bx minus c. This is called horizontal transformation, meaning because we must subtract c here. So it will shift based on the horizontal, based on the horizontal axis. You find that it's coming from this, so it's transformed according to the y equal to a times bx, and complete one cycle from bx minus c equals 0, bx minus c equal to 2 pi. So still we're setting whatever inside parentheses to one typical period or one cycle. So x should be c over b, left hand point, just like if you solve this equation here, meaning bx minus c greater than 0, less than 2 pi, you add c from both sides of the equation, and then you get bx greater than c, less than 2 pi plus c. And we divide everything by b. Cancel that, so x is going to be greater than c over b, less than 2 pi over b plus c over b. Okay. That's what you see from the next slide. That's why we have this right here. So basically solving that. And the number c over b is called phase shift, meaning shifting to the right c over b units. Phase shift basically saying that it's horizontal shift c over b unit to the right. Very similar idea as the transformation discussed in chapter 2, but the convention is called phase shift to c over b unit. And now graph of the sine cosine functions. Let's say y equal to a times sine bx minus c. The other one is y equal to a times cosine bx minus c. Period is 2 pi over b. Amplitude is absolute value of a. Left hand point coming from bx minus c equals 0. Right hand point come from bx minus c equals 2 pi. Again, between 0 and 2 pi, that's one period. So make sure you know the period states as is. Just apply some phase shift to this. So the phase shift equal to a horizontal shift c over b units. Right? This is phase shift. Now let's take a look at this. We want to sketch the graph of y equal to -3 times cosine 2 pi x plus 4 pi. Amplitude equal 3. We're taking absolute value of -3. We got 3. Period is 2 pi over 2 pi. And get 1. And we need to know the starting point and end point. So basically we setting 2 pi x plus 4 pi equal to 0. Then you solve for x. So 2 pi x equal -4 pi. Divide both sides of the equation by 2 pi, you get x equal -2. So that means that's a starting point for x coordinate for one period. And also we're setting 2 pi x plus 4 pi equal 2 pi. You can subtract 4 pi from both sides of the equation. Then we have 2 pi x equal negative 2 pi. And we divide both sides of the equation by 2 pi. Then we get x equal negative 1. So that tells us x coordinate here is from negative 2 to negative 1. And this is one period, and then the distance between them is a 1. So you take the difference, 1 divided by 4. So this is basically the increment. So that means we're gonna come up with 5 order pair and let's sketch the graph. Start with negative 2. And you're adding negative 2 by a quarter. You're adding negative 2 by a quarter is negative 7 over 4. Adding another quarter is negative 6 over 4. Simplify negative 3 over 2. Another quarter, you get adding another quarter becomes negative 5 over 4. Another quarter becomes negative 4 over 4 and becomes negative 1. So we're going to use these x values to come up with the y value. So y value equal to negative 3 times cosine 2 pi x plus 4 pi. Negative 3 times cosine 2 pi x plus 4 pi. Now the x coordinate goes here. The first order pair, first y value should be negative 3 times cosine negative 4 pi plus 4 pi. Turn out to be 0. Cosine 0 is equal to 1. So negative 3 times 1 becomes negative 3. So this is the minimum values. Second one, y equal to negative 3 times cosine two pi times negative 7 over 4, adding 4 pi. And this is negative 3 times cosine, simplify that, you get to negative 7 over 2 pi plus 4 pi. And if you combine them, it becomes negative 3 times cosine pi over 2. Cosine 90 degrees equal to 0. Negative 3 times 0 becomes 0. Okay. And then next one, y equal to negative 3 times cosine 2 pi times negative 3 over 2 plus 4 pi. So this turned out to be negative 3 times cosine minus 3 pi, adding 4 pi, turned out to be positive pi. So negative 3 times cosine pi is 0. No, cosine pi is negative 1. So negative 3 times negative 1 becomes positive 3. So now we reach the maximum here. Now next one, y equal to negative 3 times cosine 2 pi times negative 5 over 4 plus 4 pi. And this is negative 3 times cosine minus 5 over 2 pi, adding 4 pi. And this turned out to be negative 3 cosine 3 pi over 2. Cosine 3 pi over 2 is 0. So negative 3 times 0 becomes 0. And then very last order pair, y equal to negative 3 times cosine 2 pi times negative 1, adding 4 pi. That will become negative 3 times cosine 2 pi. Cosine 2 pi, same thing as cosine 0. Cosine 0 is 1. Negative 3 times 1 is negative 3. Now again, we have 5 order pairs, and then you can sketch the graph using those 5 order pairs. Then you get this particular graph. As you can see, if you graph that, -2 reach the minimum right here, -2, -3, it's first order pair, and then -5 over 2. No, this is -3. -2 right here, adding quarter, -7 over 4, right? -7 over 4 becomes 0, and then this is gonna be -3 over 2, which the peak does match with what we have here. Just basically sketch all those 5 order pairs and go back down to -5 over 4, and that becomes 0, and the last order pair, it's adding that, it's -1 and becomes -3. And then you connect those 5 order pairs, extend it, and we get 1 period of this function, y equal to -3 times cosine 2 pi x plus 4 pi. And yeah, you can extend in both directions to get more period or more cycles. Definitely no problem, but typically 5 key points is needed to sketch any translations of sine and cosine functions. And I skip the applications, so you're not responsible for those applications. Skip those applications section, but if you